Alright, today we're looking at measurements of center, and I've pulled together a little bit of data. This data is used to measure the serve speed at the Australian Open tennis tournament. I don't know what year. I didn't gather the data. It was kind of handed to me. We are trying to put together the mean, median, and mode, and then a percentile and quartile. And remember, a quartile is just a special case of a percentile. I defined in my lecture notes how to piece the mean together, at least the equation that does it. Excel, obviously, will do it for you. You just have to know what call to give it. So the function that Excel uses to calculate the arithmetic mean is average. As you see, I start the calculation with just an equal sign, type the word average, and then I need to highlight the cells where the numbers I'm taking the average of live, and then I simply push return. This number 180.95 you should see as familiar from my lecture notes. The median is not much worse. It's just start spelling the word median. So median, the instructions say to gather the information in a sequence and then just push return. There's that median, 179, was also the median that I had in my lecture notes. Now the mode, well, if my guessing is right, I can just push equal and start typing mode. Once again, it's one of the things I like about Excel's function is they're fairly intuitive. So I have a mode, and it looks like I could use two of them. This is the older version from pre-2007, and it's going to work just fine. I could just push mode, highlight the data that I want the mode of, and push return. And as in my lecture notes, the mode of 178 is what I get and what was expected. Now the percentile is moving the boundary of where the interesting information lives, if I can say it like that. The median is telling me where the center of the data is, whereas a percentile tells me where 90%, for example, of the data lives, or where 80% in the second calculation of the data lives. So let's think maybe the function I want is called percentile, so I just start typing. And there's an example of the function that I need just kind of showing up. This top one says returns the kth percentile of the values in a range. Okay, well, notice that way down here, it's got a little yellow sign in it. This function is roughly the same function. It's just an older function. So I'm going to stick with this new one. Double click it. I want the percentile, the 90th percentile of this range of numbers. So point to the range and then point to the 90%. Notice that the 90% has to be, the decimal needs to be adjusted so that it's 0.9 instead of 90%. And then I push return, and here's what I find. That in my data set, 90% of all of the data is 189.7 or smaller. That's how I would interpret that. I could do the same thing with 80% of the data. In other words, find the 80th percentile. But I'm going to have to do some adjusting because my range is going to be off just a little bit, so I'm going to move that back up. I could have made an absolute reference here so that I could do that typing. I might try that down here. Okay, let's push the return and see that 187 is the 80th percentile, which means that over here 80% of the data is 187 or less. Okay. Now this data is kind of weird because I have several 187s, I have several 179s and 178s, so it kind of messes around with your head a little bit, but still the gist is 80% of all the information in my data set is a number 187 or smaller. Now, quartile is just a special case of a percentile, but maybe there's a function for quartile. There, I start typing it in, and it says yes, there is quartile.exe. I'm going to use that. I need the array. This time I'm going to make that an absolute reference so that I can just do some copying and pasting. So I press F4 at that point, and then point to the quartile that I want. I want the first quartile. So that's the percentile when the percentile is 0.25. So 25% of all of my data is going to be smaller than whatever this number turns out to be. So let's find out. 178. So 25% of my data, 178 or less. Notice it's not perfect because of, once again, the strangeness of the data set. Let's put in the second and third quartile. I can just do the copying because of the way we set up the function to be an absolute reference to the data series. And then I just keep changing the quartile. I would like you to see that this is exactly the same calculation that I should be getting from the percentile. So let's try out the calculation, but let's use the percentile instead of the quartile. So I'm going to refer to this sequence of numbers. I'm going to make it an absolute reference by pushing F4, and then I want the first 25, or the first quartile, the 25% or less. And then I should be able to just copy that down given how I put the function in. And so you can see, I mean, do we really need two functions, one for percentile and one for quartile? No, not really. I want you to see that they are the same. Now we had one other measure of center, and that measure of center was this geometric mean. And the question that would be in my mind is, well, when would I ever use it? And the answer to that is when I am working with growth factors. So what's a growth factor? Well, you look for the growth factor in my lecture notes. But what's more important right here is how do I calculate it? I calculate it as the ratio of the most recent number, the most recent measurement, divided by the measurement just 1 month, in this case, older. How do I interpret this? I interpret this as that during the month of January, the amount, or the growth factor, in terms of, I believe this is price per share, of the Apple shares of stock, is 1.0654. Or growth factor, if I wanted to turn it into a growth rate, subtract 1. So I had a 6.5% growth rate just in this 1 month alone. Now if I get this in correctly, I should be able to just copy the other growth factors down so that I get a column of data representing the monthly growth factors for the Apple stock price. Okay, so now I can use these growth factors to get this geometric mean. So geo mean. That's the call for the geometric mean. I want to identify the data I want to take the geometric mean of, close the parenthesis. My geometric mean is 1.025 roughly. So what is this telling me? This is telling me the average rate of growth per month of the Apple stock. Well, that's a pretty good growth rate. That's 2.5% per month. That's pretty high. Okay, so there's our measure of center. The next thing that we would pull up, or the next video that I will give, is the using Excel to get a measure of dispersion, which is range, interquartile range, variance, standard deviation. See you then.